Hello, this project is Conway's Game of Life, presented by Anthony Montes, myself, Hayden Kowalchuk, Johnathan Nguyen, and Rebecca West, and our team name is Team 8 Technologies. This game is a zero-player game, meaning that the evolution in the game state is purely determined by an initial state, and then is only advanced each generation. There's no further input once it's started. And as for responsibilities and teammates, Anthony Montes worked on this presentation and the CSS and some animations throughout the web project. I worked on writing the actual Conway simulation, as well as the HTML and CSS to display it, and also helped organize the project as a whole and schedule meeting times. Johnathan Nguyen worked on the user authentication and registration pages, as well as helping with this presentation. And Rebecca West did thematic CSS styling, the UML diagram, and again worked on this presentation. Without her help, this whole project wouldn't have looked so cohesive.
Hello everyone, my name is Anthony Montes, and today I'll be presenting the game mechanics and game design for Game of Life. When you start playing the game, you start at the home HTML file, and you'll be presented with the option to either sign up or log in to play the game. After successfully registering an account and logging in, you'll be shown to a screen where you can start playing the game. From there, you'll be given a select number of options, which you will see on screen, that you can choose from a select presets of lexicons that can animate based on user input, or you can draw your design by clicking and dragging your mouse over the grid. So the game objective, this served as a premise to how the game must work. Following these rules is very important for our game to work. For the game objectives, the main priority we must follow is following any of these rules as listed here. For the user input, all we were looking for, or the general requirements, was signing up, logging out, or start playing the game, or stop the game, or drawing the design on the grid, or you may select the presets. You can reset the game whenever you want, or as soon as you select a preset or you draw your grid, you may start incrementing generations. When you click on these buttons, you will see the output immediately on the grid. The cells from the various patterns throughout the course of the game is all based on user input. The design is very simple, very user-friendly. Beautiful grid design for a nice aesthetic. As you can see here, we've carefully listed the rules that the person must follow, and the controls are easier to see. And as soon as you click on these buttons, all immediate actions will display on the grid. And as you can see here, the grid is a black border, but with a nice gradient PNG background behind it. But as you soon click or draw over it, you'll see the nice coloring effects or gradient effects.
We wanted to pinpoint any bugs to ensure a smooth and efficient user experience. The data collection and storage for user authentication, grid design, and the entire function of the game was a great challenge for us. However, once we powered on through, we finalized the testing with validators for all the files. Our test case involved registration, So overall, we check the results of the username and password to ensure values and no empty fields, as well as local storage to authenticate, match, and save existing and new users with their passwords. The UML diagram covers the main functions of the user, cells, and the game board, such as the abilities the user does from start to finish, the state conditions of a cell's life, how it evolves during stages, and what is being printed on the game board to be visual and manageable as this slide displays. The Scrum framework helped us complete our project in about a week with lots of communication with clear and doable member roles, responsibilities, as projected through Discord, easy access and sharing through GitHub repository, and most importantly, efficient use and production of meeting the basic requirements from the rubric.
Alright, so here's the general homepage of our game. This meets one of the requirements of having a button for a login profile for each user. So the sign up button here will allow a user to register, and upon successfully registering, it will auto-link relocate to the login page. Or if you already have an account, you can just simply click on the existing user page here and it will direct you to the login page as well. So here's our simple sign up user interface. It's a standard display just to create a username and password, and it has a beautiful CSS animations done by our teammates here. So here's the code for our registration page. We decided to use local storage to store our users because it allowed us to save key and value pairs within the web browser. So the first thing I did here was to create a variable to get the user info within the local storage. The local storage is a storage for each individual web browser. So what I mean by that is if you created an account on Google Chrome, it would only be stored in Chrome's web browser on your computer. But let's say you went to Edge on your computer and you tried to log in with that same account, it would not log you in. You would have to create another account because the local storage on that web browser is completely different than Chrome's web browser. So before the register function gets called, we have a series of validation for signing up on the function check fields here. First, our app ensures that the username fields and password fields are not empty. Next, we have a for loop that loops throughout the local storage array and checks to see if the username entered is an existing username. Lastly, we have a password verifier to ensure that the user chooses a password that is not less than 8 characters. If the user doesn't meet all of these requirements, we have a function that displays the error message in red, and then it will alert them to fix the issues in red. So if the user signs up successfully, the register function will run, obtain the values in the text fields, creating a new user with key and value pairs here. And then after that, it will push it to the array we parsed through in the beginning, and the local storage can only save strings. So since we're storing the object's user info containing the username and password, we'd have to use stringify to the new user. Lastly, we want the successful signup to successfully relocate us to the sign-in page or the login page, which is what this last part of code is doing. Alright, so here's our login user interface. It's pretty similar to our sign up page. And here's the code. So once our login button gets pushed, we have the authenticate function running. This function first parses through and gets the user info from the array from the local storage. Then it gets the value of the text fields that were just inputted, and it checks to make sure that the username is in the array. And if the username is in the array, then it checks to make sure that that username and the password match. The key and the value have to match in order for it to be directed to the game page, or else they'll be getting a username and password mismatch right here.
This grid UI is created dynamically in JavaScript. Each time the user loads the page, it reads a CSS3 variable, well, two of them, called row number and column number to determine how large to make the grid. And then once that is determined, it will find a grid element and then start adding divs up to the amount of rows and columns that are requested. The default is 64, so you will get a 64 by 64 pixel grid, as it were, to display the game. And then for the gradient effect that's used, the background of this grid is set as a image. And what we do is when a cell is alive, the background color of that is set to a blending mode, and we set the color to white. This is so you can see the rainbow underneath, much like a traditional scratch art. And then otherwise, if a cell is dead, we leave the background color as black so that it blocks the background. Now here's the main code that makes all of this function. On the left, we have advanced generation, which is the entire crux of the game. That goes through, and for every pixel in our grid, there is or each cell, it will check how many neighbors are alive, and the code for that is in the middle column. It looks kind of long at first, but basically to support wrapping, we check that for previous x, if we would be one less than 0, we set it to the max x. Same for next x. If we were to go over the maximum, then we would set it to 0. And similar for y. Just that way we get a nice clean wrapping around all the edges. And then we just have our cardinal directions: northwest, north, northeast. And these are just a simple array of those values to determine if we're a certain cell, what would be the cell coordinates, northwest of us, southeast of us, and so on. And then finally, to determine how many neighbors are actually alive, we have this big long addition at the bottom, let neighbors equals. And what this does is it grabs the element in our grid array for each of those 8 surrounding cells. We sum all those to finally determine how many neighbors are alive. And then back on the left, at the let neighbors equal count neighbors, after we've counted that, we then just go through the basic 4 rules of Conway. We say if we are currently alive and we have 2 or 3 alive neighbors, then we continue to be alive. The next rule, if we are alive and there is more than 3 neighbors, we are overcrowded, and thus on the next generation we will be dead. The next rule, if we are currently alive, but there is only 1 or none alive cells next to us, we then die from being lonely. And finally, if we are a currently dead cell and we have 3 neighbors alive, then we will be resurrected in the next generation. So all of that handles the backend JavaScript. We handle updating the grid for each generation. And then all the way on the right, we have Conway draw, which then will read that grid array. And we'll go through in our HTML DOM and find all the elements for each row and column. And we remove the on class for every cell, and then we might add it back if we determine we are alive based on the work we did in advanced generation. And here is a live demo of the web app going through all the features we have written, including user registration, login, and Conway's Game of Life itself. Here's our main page for the Conway's Game of Life, showing you either a sign in or a sign up. So let's go ahead and sign up. We'll try and make an in-class user, which I have purposefully already made, and we'll see that it will fail. Username already taken. Okay, so let's put that to 2, and let's put the password as pass123. Something a little more secure. Oh, another error. Password is too short. Okay, let's just do password 1. All right, so now let's sign in as our new user in class 2 with password. Oh, and that doesn't match, right? It's password 1. So here we can see our Conway's Game of Life showing the 4 rules, our controls, left, right, and middle mouse click, and our game board. Let's go ahead and just draw some squiggles on here just so we can kind of get something going. And we can advance 1 step and we'll see how this plays out. or we can just go ahead and turn on animation. And we can see some nice, we got a couple still lives, and so we can stop that. Let's go to a smaller grid, and let's just make a single glider, and we can see that it glides down correctly, or if we would rather watch one single generation at a time, we can click through, or we can skip 23 at a time. Or we can have a really small grid and just see how that would play out. Generally, not much happens on these very small grids. Right, and so that's actually a 4-block still life because it wraps. Yeah, so now we have a couple small oscillators. And that's it for the main demo of our Conway's Game of Life. And here's some in-progress videos while we were writing the project. First up, this was one of the first just kind of designs where we had a basic grid and we could advance through different generations. In this one, I added some presets and more buttons to advance, and also just some basic animation. This clip was showing some kind of colors that would indicate how long a certain cell was alive for, and as a cell was alive for longer, it would darken, new cells would be lighter. We ended up not using it, but it was a neat effect. Finally, this one we just went crazy with bloom and color and this blur filter. We didn't use that either. And we finally settled here with the scratch art design of color on black.